Hello, I'm Nathaniel, and today we will now do question 4 of step 2, 2021. Sketch the curve y is x times e to the power x given the coordinates of any stationary points. First we had to get the coordinates on the stationary points. Well, because that's what I would usually do first, but either way you could draw the graph first, but in this video I will show the stationary points first. So, how do we find the stationary points? We use the derivative. What is the derivative? It's just the measure of change. For this function is x ex plus ex. I won't go through the mechanics on the derivation in detail. I covered it in my A-level mathematics video. But using these rules and the product rule, you can show that dy over dx of x ex is x ex plus x. So to find stationary points, we have to find dy over dx equals to 0. So we can factorize the above expression as x plus 1 ex equals to 0. Since e to the power of x is always greater than 0, x plus 1 equals to 0 and x equals to negative 1. Substituting this in the equation gets y equals to negative 1 over e. Either way, or doing the graph first or doing the stationary points first, you will get the graph shown on the right, which is drawn using Desmos. Desmos is one of my favorite programs to draw graphs on, simply because the interface is very clear. I'm not sure you can see the whole graph. I think you can see it right now, right? So you see the red graph is the graph of x times e to the power of x, and the blue graph is the inverse. Why the inverse? Well, we'll go through it later and we'll show you why the inverse is important to this discussion. The function f is divided by fx, where a is the minimum possible value, such that f has an inverse function. So why? How do we do this? Because in order for this function to have an inverse, we must say that it is 1 to 1. Basically, all values of x back to exactly one value of y. An example of a 1 to 1 function is e to the power of x. What is the value of a? Well, a is negative 1 due to it having a stationary point at x equals to negative 1. Let g be the inverse of f. So, if you know from functions, you can say that inverse is the reflection over the line y equals to x. And this is the inverse of the function f. The blue graph is the inverse of the red graph. For each of the following equations, find the real root in terms of the value of the function g, or demonstrate that the equation has no real root. Let's start with question A. We multiply both sides by e to the power of x to find 5x ex equals to 1, and then we solve for x ex to get 1 over 5. Then x, using the definition of g, we get g of 1/5. There, that was quick. 2x ln x plus 1 equals to 0. So, x ln x, we have to solve for this, is negative half. And now we're going to use the substitution u equals to ln x. We are going to use this substitution throughout the whole question. So, we just box it up. Great. So, eu equals to negative half. U equals to g negative half. But wait! Doesn't this value not exist? Yes, this value doesn't exist because negative half is less than negative 1 over e, as we can see the domain of the g function. So, no real root exists. There. 3x ln x plus 1 equals to 0. Basically, we just change the 2 to a 3 and get g negative 1 over 3 due to the ln substitution. And since ln x equals to g negative 1 over 3, using the substitution, x equals to e g negative 1/3. So, x equals to 3 ln x. Now this is where it gets good. We use the substitution to get eu equals to 3u. So 3u e negative u equals to 1. Multiply by both sides by negative 1 over 3 to get negative u e negative u equals to 1/3. U then becomes g negative g 1/3. And so what this means is that we can use the substitution back again to get x equals to e negative g 1/3. Actually, it's negative 1/3. So, given that equation x equals to 10 has a unique positive root, find this root in terms of a value of the function g. X to the power of x equals to 10. How are we going to use this in terms of the function g? This is how I first discovered what in the method is known as a Lambert W function and what in this question is known as the g function. First, we decompose x to the power of x equals to e x ln x. Now you might be thinking, this will make the problem harder, not easier. Well, the reason why we're doing this is because we use x ln x equals to ln 10. Familiar or not? We use the substitution again. UEU equals to ln 10. Then U equals to G ln 10. Using the substitution back and taking e to the power on both sides. Since e to the power of u is x, we can therefore conclude that x equals to e g ln 10. That was quick. I hope that enlightened you about the wonders of this marvelous g function. And this is also known as the Lambert W function, also one of my favorite functions in mathematics. You can go look its article on Wikipedia, and one common property of this function, as you can see, the inverse of xex has two branches, as you can already see in the Desmos graph. This basically means that you have the normal branch which can use throughout the question, which is known as the W0 or the Lambert W0 branch, and then there's the other branch which goes down the bottom, hanging asymptotically to the y-axis, known as the Lambert -1 branch. Isn't that amazing? Well, anyways, see you in my next step video.